Okay. Alright, I'm going to try this out. I have no idea if this is going to work or not, but we're going to give it a shot. I have a webcam. There we go. You might be able to see this. There we go. Good. Okay, so I'm going to go through. I have a webcam here. I'm going to be recording my lectures from now on, putting them up on YouTube. So in case that you're going to be gone for a day or 2 weeks, depending on whatever, it doesn't matter. You can still go through, watch these lectures, and stay caught up. All good? Yes, sir. Oh, this is maybe 110. This is 207. No worries. Alright, I'm going to give this a try today. The audio may be just absolute crap. I don't know. This is my first time trying it out. But we'll see what's happening. Alright, all good? Cool. Alright, so today we're just going to go through and basically answer all the questions from the exam. Okay? So, what is the molar mass of Ga? Ga, gallium. Gallium's a fun one. So how do you go about finding the molar mass of gallium?
You go to the, what is it called? Periodic table.
Periodic table. So you can go through to the periodic table. Oh, I need my pointer stick. I need a pointer stick. Alright, pointer stick. Gallium. There's the molecular weight right there, the molar mass. So you can go through and just look at these guys, but we have the same number twice. Why did I pick this one?
Because it's grams over moles.
Yeah, it's grams over moles. It's this many grams over per 1 mole. This would mean I have this many moles in 1 gram, but that's not what it is. On the juggers. Okay. How many electrons does this element have? So let's run through it real quick. We know this guy is helium, He, right up here. How many? What does this number mean? The bottom number. Protons. You can also tell it has that many protons from number 2 on there. What does this number mean?
Neutrons? No.
Neutrons?
Neutrons plus electrons, right?
No, almost. Neutrons plus protons. Neutrons and protons. This is called, the top one is called the mass number. So what are the things that have mass in an atom? Protons and neutrons. So the mass number, let's take the stuff with mass, add them together. Okay, but the question is, how many electrons does this have? So we know there's 2 protons. Protons are positively charged. What's the charge of this guy?
Positive. Or it's cancel out like 0.
Yeah, it should be 0, right? So if there's 2 positives, how many negatives do we need?
2.
2. So how many electrons are there?
2.
2. There we go. Okay. How many atoms are in 28 grams of nitrogen? All right, so this is... Okay, this isn't even, yeah. So some of these you can actually answer without doing any math whatsoever. But let me get, this one is not one of those. If I do that, hopefully that doesn't screw up the video. Alright. So this is one of those grams, moles, atoms guys, right? So for that, you're going to need 2 things. You're going to need the molar mass of nitrogen. So what's the molar mass of nitrogen? Where do you get that? Periodic table. Look up at nitrogen, it's 14.007. And again, that's grams per 1 mole. And then we need Avogadro's number, 6.022 times 10 to the 23rd. In this case, it's going to be atoms in 1 mole. Okay. We are trying to get to atoms. And so which one of these guys has atoms in it? Avogadro's number. Put that guy first. So what do we need to cancel now? Cancel out moles. Well, what? This guy has moles. Flip them. Moles are gone. We need to cancel out grams. There's the grams up there. And now we just go through and move on. One thing that you can do, if you don't have a calculator on hand and you want to just do this in your head, 28 divided by 14 is 2, right? So 6.022 times 2 is, what's 6 times 2? 12. So it's going to be 1.2 times 10 to the 24th, right? Just move it over, you have to move over the decimal point. 1.2 times 10 to the 24th. Yeah, I mean, I get it. Calculators are that nice little security blanket that keeps you nice and warm. Make sure you know you're doing it right. Hey, self-checks are never bad. Okay, there's that. And most of you got it. I would say, like, there was no question that really stumped anyone, or stumped everyone. All right, if an atom absorbs a photon of light, what happens to the atom? So, electrons go up in energy level, down in energy level, protons released, neutrons are gained. So remember, yeah. If you're absorbing light, you're absorbing energy, if all of a sudden I gain a whole bunch of energy, do you think my energy level is going to go up or down? Up. So, there's that. This one's fun. So, how many moles are in 4.3 times 10 to the 22nd molecules of phosphoric acid? That's H3PO4 is called phosphoric acid. This is one where you can get rid of a lot of things just by looking at it. How can you get rid of a lot of things just by looking at it?
Because it's asking for moles, and you can just get rid of grams.
Exactly. So these guys, oh man, I gotta recalibrate this. So yeah, you can get rid of 2 of them and have a 50-50 shot just by looking at the units. Okay. Okay. Those are gone. Now we have these 2 options, right? This one, 2.6 times 10 to the 46th. That's huge, right? That's a huge number of moles. The reason why we use moles is so we can use nice same numbers, like 2 or 4 or 6. It's one of the reasons, same reason why we use dozens of eggs, right? I'm going to go get 1 dozen eggs instead of 12 eggs. So, just from that, this looks like it's a pretty solid bet. If you wanted to go through and do the calculation for it, though, how would we go about doing that? We are going to moles, right? And what do we have? Molecules. So that means we're going to be using, which one of these? Avo's number? Avo's number. So we want to get moles, so we're going to put moles on top. and 6.022 times 10 to the 23rd. We need to get rid of moles. Or I'm sorry, we need to get rid of molecules. So we'll put molecules on top. 4.3 times 10 to the 22nd. So at that point, you can just plug and chug. This divided by this, and you will get your answer. A different way you can go about doing it, right, is turn this into the 22nd by moving it over this way. What's 4.3 divided by 60? I don't know. I guess you can't really do that in your head.
I'm gonna guess like 13.
0.007. Yes, sir. Hold on. Moment. All right. The number of blank determines the identity of the element. So, which one of these, protons, neutrons, or electrons, determines the identity? Protons. I mean, yeah, you can see it right there. But, if nitrogen gained a proton, what would happen to it?
Then it'd just be another element.
It'd be another element. Which one, though? If it gained one more?
Oxygen.
Oxygen, right? So if you wanted to get gold and you had a whole bunch of lead, you would need to get rid of how many how many protons?
Like 2, 3.
3. Okay. Atomic number of oxygen is 8. This indicates that there are 8 protons. So it's the same idea there. Copy. A nuclear particle that has the same mass as a proton but no charge is called a neutron. So you can just remember, neutron is neutral. Neutron is neutral. I can kind of see why someone would say isotope, because what changes if you have a different isotope? If you change protons, you change the element, right? So if I change electrons, what do I have? Ion. If I change the neutrons, I have a isotope. So get that. All right. If the electromagnetic radiation A has a lower frequency than B compared to B, the wavelength A is longer, shorter, equal, or exactly half. So, what do I mean by that? Basically, I'm saying if the frequency goes down, what happens to the wavelength? Does it get bigger? Does it get smaller? Right? So, if you kind of remember our thing, you have the wavelength, meters, and we multiply that by our frequency, and this will get us the speed of light, right? So we're multiplying these guys together, and we have the speed of light. Speed of light is constant. So if this number, so basically what we're saying here is something like x times y equals c. If y goes down and c stays the same, what happens to x? So if I take 2 times 2 is 4. If that 4 stays the same and I change this number to 1, what does this number have to do?
4.
Have to be 4. So did that number go up or down? It went up. See what I mean? That's what this question is asking. How many molecules are in 3.7 moles of this guy? Again, how can we go through and just automatically nix a couple answers? What answers can we get nix out of this?
You can, the grams.
Grams you can get rid of. So based on the other answers, the numbers, what just makes sense that you can get rid of? Like, there's no way. If I said, Eli, I'm gonna guess your weight, right? And I'm gonna guess 300,000 pounds.
Yeah.
Is that at all right?
No.
No. If I said, okay, I'm gonna guess your weight, 0.006 pounds. No, right? So, which one of these is a reasonable number? What about this one? 5.3 times 10 to the negative 24 molecules.
That's pretty small.
It's a small number. In fact, it's less than 1, right?
Yeah.
So we're talking about molecules. Can I have half a molecule?
No.
Can I have less than 1 molecules? Or like, somewhere between 0 and 1 molecules?
Mm-hmm.
No. So this guy is out, right? What about this number? 340.
It doesn't seem right because there's a, like, I don't know, it's just not.
Where how many molecules are in 1 mole?
Is it 6.22?
6.022 times 10 to the...
That's why it can't be right, because there's no point.
Yeah, I mean, 6.022 times 10 to the 23rd, right?
Yeah.
Is this number really big?
Yeah.
Yeah, 1 mole is frickin' huge, right? 1 mole, remember, 1 mole of strawberries covers the entire Earth 5 miles deep. So, mole, when you say, like, yeah, I have 1 mole of something, it's a huge number, right? How many moles is the question asking for?
3.7.
3.7. So it's a huge number times 3. It's going to be a huge freaking number. So, 340, does that make sense?
No.
Not really. So, without doing one stitch of math, you can go through and get to the right answer with this. Okay? Not all questions are going to be like this, but when you do see a question like it, where you have a whole bunch of different numbers that are all, wildly off, stop for a second and do what I call a sanity check, right? If I go through and I'm like, okay, I'm going to guess how many people are in this room and say 3 billion, that's not sane, right? Do a sanity check. It doesn't take terribly long, and you can knock out a fair number of questions. Okay. A photon is emitted from when an electron moves from one energy level to a higher energy level, lower energy level, into the nucleus, into another position on the same sublevel. So, when does a photon leave? It's whenever an electron goes down. One way you can think about this is if a photon is going from high energy to low energy, it's relaxing. What do I do whenever I relax? I lay down and go. I put out air. Electrons put out photons. I will say the electron stuff, wave energy, that stuff is probably the hardest part of this test. All right, what's the mass number of this element? So again, it is 4. So how many neutrons would this element have? mass of carbon tetrachloride, CeCl4, is 153.1. So I just gave you that there. How many grams of carbon tetrachloride are needed to have 5 moles? Okay. So let's go through and do, another sanity check real quick. Okay. Remember, we have this many grams is 1 mole, and we have 5 moles. So is it going to be bigger or smaller than 153? Bigger, right? Is it going to be a huge amount bigger?
No.
Not really. So let's go through and look at these. Maybe 5 grams?
No.
No. 30 grams?
No.
No. So we can already knock off a couple of them. Now we have these two guys, and they're the same number, right? Almost. Almost the same number. But how many sig figs does this guy have? The second answer.
Is it 5?
5. 5 sig figs there. How many sig figs?
4.
4. So this is just a straight sig fig thing. Again, another question where didn't have to use much math. Okay. Electron goes from high to low. What do you see a photon is emitted? So we got that yet. Alright. So you haven't taken the exam yet, right? You want to take it? Say what? How much time do we have left? 27 minutes. Probably not. So we're going over the exam right now. Yeah. Do you have any other things to make up? Assignments or anything?
Yeah, I think.
Okay. So how about head outside? Other people are taking the exam outside. Head out there, work on stuff while we go over the exam. And then tomorrow, be ready for the exam. All good? All right. All right. How many neutrons does this element have here? So again, first off, 16, yeah. But you can get 16 by 31
Minus 15.
minus 15. Done. Rutherford gulf oil experiment. Most of the particles did what? This one was a thing. Some people missed this one. Let's kind of go through the wrong answers first. Were absorbed by the nucleus? Not really. That didn't happen. Were deflected by the nucleus of gold atoms? Yeah, that did happen. But did it happen often or did it happen rarely? It was a rare occurrence. And what are we looking for? Most of the time. Okay. What about this one? It hit the nucleus and bounced straight back. That happened rarely, but we're looking for what happened most of the time. Most of the time, they went straight through the gold foil. Yeah. This is another tricky one. 1 mole of an element is 6.022 times 10 to the 23rd, but it's also equal to x grams when x is the atomic mass. So think about it up here, right? Remember that these ratios are also equalities, right? So 1 mole equals 6.022 times 10 to the 23rd atoms. Like 12 inches equals 1 foot. So this many grams equals 1 mole. So it's both of them. How many neutrons are the most common isotope of aluminum? So, where's the mass number in this? You guys remember? Right here. But what do you have to do to it? Round it. What are we rounding to? 27. So 27 minus 13, 14. There's the how many moles are in 30 grams of phosphoric acid? Yeah, this is another example where you can cross out your grams, and now you're kind of stuck between two things. We're looking for moles. This is another example where you have a very tiny number and a more sane number. But if we wanted to go through and actually do the math on this one, what would we have to do if we wanted to go through and do the math? So what?
You'd have to add all those things up.
You got to add all those things up at first. So these numbers are pretty far apart, right? So I don't feel bad about rounding this. So we have 1 for hydrogen, but there's 3 of them. We have phosphorus, where are you? 30.9, so 31. And oxygen times 4, so that's 16 times 4, that's what? Ah, geez, it's Monday. I know.
Oh, it's Monday.
30, 64. Yeah. Okay, so 8, 9, 98. 98 grams in 1 mole. Right? What are we looking for? In the question? No, what are we looking for? We're looking for moles, so that means that mole needs to be on top. We got to get rid of grams. Only other grams is in the question at 30. So 30 divided by 98, that's going to be about a third, roughly. So it's going to be 0.306. So, when taking these big exams, usually, I'm kind of assuming that everyone in here is going to be taking AP Chem or some other AP math course in the future. When taking these big, you guys took the PSAT, right? Yeah. Right? You had an entire section that had math, no calculator, right? This is one thing you can do if you're like, how are they expecting us to answer this without a calculator? Look at it. Look at the answers. Usually they're, a little bit weird, where you can get rid of some of them. Do a quick sanity check. Molar mass of lithium fluoride is 25.94 grams per mole. How many moles of lithium fluoride are present in 10.37 grams? In this case, it's another one of those things. We can't really go through and cancel out by unit this time around. They're all moles. We want to have moles, so moles are going to be on top over 25.94 grams, 10.37 grams, to cancel out. And now it's 10 over 25.6. So if we have a fraction that's 10 over 25, is it going to be greater than or less than 1?
Greater than 1.
10 over 25?
Oh, less than 1.
Less than 1, right? So if it's less than 1, you can go through and cross out all of them. Yes? Sure. Okay. All right. So this was the only calculation that you needed to do with frequency, wavelength, energy.
Yeah.
All right, but you had to do the entire thing. So a photon of light has an energy of blah, 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 joules. What is the wavelength of the light? And all of these guys, you can't do the, let's guess the right answer trick. No tricks here, you just have to go through and do. Okay. You have to just go through and do the math. Okay. So what are we looking for? Wavelength. We're gonna it's gonna be nanometers, but let's just do meters for now, because that's a little easier. We're looking for meters. I gave you guys Planck's constant and the speed of light, so I'll write those guys up here. .8 meters per second, and 6.626 times 10 to the negative 34th joule seconds. Okay. So out of all this, speed of light, Planck's constant, this many joules, which one has meters in it?
The speed of light.
Speed of light. 3.00 times 10 to the 8 meters per 1 second. Did I put that in the right way? Do I need to flip-flop it?
No, it's the right way.
Okay.
I
So,
believe-
I did do it, so whatever it is, imagine that it's going to be going up as soon as I get to it. Okay. Right way? Do I need to flip it?
I think it's good.
We're all good. Cool. So now I got to get rid of what? I need to get rid of meters or seconds?
Seconds.
Got to get rid of seconds. What has seconds in it? No? Yes.
Yes.
Okay. Is that going to be on top or bottom? Top. 6.626 10 to the negative 34th joule seconds. Seconds cancel. Now what do I need to get rid of? Joules. Hey, I got joules right here. 3.98 times 10 to the negative 19 joules. Joules cancel.
Wait, shouldn't it be on bottom?
Oh, you're right, it's on bottom. Actually, there. Put that there. I planned that. All right, and then joules cancel. And then you just plug and chug from there. So, plug and chug it. Okay. How many atoms are in 2.5 moles of copper? So again, we can we can get rid of a fair number of these guys. 64 atoms. Do you think that that's reasonable? No, not really reasonable. What about 4.15 times 10 to the negative 24th? That's a fraction of an atom. That doesn't work either. So we're just left between these guys, right? If you wanted to go through and, again, kind of do this in your head, if 1 mole is 6, and we have 2.5 moles, what is it going to be roughly? So what is 6 times 2? About 12, right? If I wanted to write 12 in scientific notation, what would I have to do? Move the decimal place over, right?
Yes.
So instead of 6.0 times 10 to the 23rd, it's going to be to the 24th. And that will get that answer there. Or you can go through and, do it out the long way. How many protons are in boron? There's 2 ways of figuring this out. What are the 2 ways you can get for this one? What's one way we can figure out the number of protons? I'm sorry?
It says it on the bottom.
Yeah, it's on the bottom. Right? This bottom number is number of protons. Right? What's another way? Look at the periodic table. Find B for boron. And look at that number there. So. Okay. How many grams does this many atoms of chlorine weigh? Again, most of you guys are getting this idea. You can get rid of the obvious ones that you need to get rid of. And now we have 2 options. We have 17 grams, which is like about the, size of a container, right? Something I can hold in my hands. That's about 17 grams, right? And then we have 6.43 times 10 to the 48 grams. That's about as many grams as you can haul in a dump truck or something. Even more than that. That's huge number. So sanity check wise, this one is kind of suspicious. Sanity check wise, this one's a little suspicious. But we can kind of go a little bit further than that. Does this number look, think about that many number of atoms. What does that look like to you? 3.01 times 10 to the 23rd. Does it have a relationship to anything? 3.01?
Speed of light. No, what is it?
What's all those numbers? 6.02. 3.01, 6.02.
Oh, so it's just half that.
Half, right? So how many moles do you have? Half a mole. If you have half a mole, what's the molecular weight of chlorine? Up on the periodic table there.
It's half.
It's going to be 35.4, so what's half of that? 17. Okay. So again, this is kind of where those PSAT skills come into play. Recognizing, hey, that's half of a number that I need to know. And you can do some quick math. All right, which of the following statements is true about modern atomic theory? Most of you guys got this one. Atoms of the same element have different masses. Is that true? Yeah. You have isotopes, right? So you can have, hydrogen 1 or hydrogen 2. You can have carbon 14 or carbon 13 or carbon 12. Those, that number on the back end is how much they weigh. But why are the other guys wrong? Why is it that atoms may be divided in ordinary chemical reactions? If I divide an atom, what happens?
It splits.
Right? But if I split an atom,
It blows up.
yeah. You guys know how... Yeah, Hiroshima and Nagasaki. Splitting atoms. Yeah.
I think I learned that from a movie one time.
I wouldn't doubt it.
Like,
But, so, is that a ordinary chemical reaction? No. So, you can split atoms, you can divide atoms, but it is by no means ordinary. That's going to be a rare occurrence. Atoms can never combine with other atoms. Can I put two atoms together? And can they combine?
No.
Yeah.
I can't.
Think about, like, if I take two hydrogen atoms and an oxygen atom, smoosh them together and make them kiss,
Oh, okay.
what do I get?
H2O.
H2O, water. So that's true. And then cathode ray tubes are composed of protons. The cathode ray experiment, old J.J. Thomson. What was inside of that cathode ray tube? Was it protons? It was electrons. Electrons. Thomson was the electron guy. All right. Almost done. We got a few more. How many grams are in 3.7 moles of sodium oxide? This is one. Well, we can get rid of one of these guys, right? You can get rid of moles. That's fine. The other guys, we have a little thing we can do. Again, to figure out the molecular weight of sodium oxide, you have to go through and do sodium, which is about 23, times 2, so it's 23 again. Oxygen, which is 16, 3, 2, about 62 grams in 1 mole, right? Well, how many moles do we have? We have about 4 moles, right? So if we have about 4 moles, is this number reasonable? Not really, because it's going to be, if I have 62 grams in 1 mole, and I have 4, that means it's going to be a bigger number than 62. So that many grams is not going to be right. Then you actually have to go through and do a calculation to figure out the difference between these two. 62, we need to get rid of moles, so the moles are going to be on top. 3.7 moles. For the moles to cancel, multiply. 62 times 3.7, 230. An atom is electrically neutral because why? How do we know that we have a neutral atom?
Because they cancel out.
Yeah, protons and electrons cancel out. Protons are going to be positively charged, electrons are going to be negatively charged, so you need the same number of charges to cancel each other out. Alright. How many grams is 2 moles of nitrogen? This one's mean. This is a rounding one. So this one we know is wrong. Sig fig wise, they're all 3 sig figs. We can go through and do that. Nitrogen has a thing of 14.007 grams per 1 mole. We have 2 moles. So it's going to be 28.02, right? If I multiply 14.007, it's going to be 28.021. I only take the first 3 sig figs because we have 3 sig figs up here. Are we going to round up or down? We round down. 28.0. Okay. Isotopes of an atom of an element have different numbers of what? So again, what's the thing? If you have an isotope, it's different numbers of neutrons. Ions are what?
Positive or charged.
Which means that a different number of electrons. And if it's a different element altogether, you have a different number of protons. There we go. How many neutrons are in boron? We've kind of already gone over that a bit. See if there's any other ones that were kind of off.
Would you like a 3-point? No.
Yeah, no one picked that. Every so often I have. So in this year in AP Chem, I give them a pre-test that's optional. But you know the curve I gave you guys?
Yeah.
They get a curve on every single exam if they do the pre-test. If you don't do the pre-test, you don't get the curve. Basically saying, if you don't want to study, that's fine, but you're not going to give you a curve if you don't study.
What atoms again? Don't they shoot more like a whole bunch of what's it? How do they split atoms again?
How do they split out? There's a lot of things.
I thought the words they used like
yeah, that's I think like the water yeah, they basically just take atoms, accelerate them.
what makes it important to work like that?
So one, it's not just one atom. So what you do is you take one atom, and you do it for one atom, and that will get you something. And that causes other guys. So you do have like that'll probably get you up to maybe like a 67. So,
Okay, so on the pre-initial things, are we supposed to take a picture and send that to you? Oh my goodness, I may need a new pay for them.
yeah.
I'm running around the nursing to check on the temperature, and then so if I'm not back, just pop in to check on my kids. But I don't think it's anything. But I just want to make sure.
I'll tell you what, I remember you were here.
And I did give it to you for the initials on Tuesday.
Yeah. I will say this. Write on a piece of paper that you did. Just remind me of this conversation.
Okay.
And then, there you go.
Okay, thank you.